Hi listeners, you are welcome to the continuation of our online tutorial class from your favorite student ScoreBooster, your online tutorial provider on UTM or NECO and active exam. For today's presentation, we shall be discussing the concepts of temperature scale conversions. I am Bangwade AA. Before we proceed, we need to consider the learning outcomes of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to define temperature scale. They should be able to state the examples of temperature scale. They should also be able to do the interconversion of two different temperature scales. And lastly, they should be able to solve relevant UTM questions relating to temperature scale. Now, to start with the temperature scale, the summary of the various temperature scale we have is presented in the table shown below. But before we move to that, we have to realize, as discussed in our video 22 on temperature, that a scale of temperature is a scale based on any thermometric substance. I repeat, a scale of temperature is a scale based on any thermometric substance. And the fixed points normally used are the temperature of the melting ice, which is the ice point, and that of the boiling point, which is the same point under standard atmospheric pressure. We also made us realize in our video 22 that in converting any temperature, the essential factor we have to take note are the steam and the ice point of each temperature scale. For example, the steam point generally will be represented by x 100, while under centigrade the steam point of centigrade is 100 degrees Celsius, while the steam point of temperature in Kelvin is 273 Kelvin, while the steam point of Fahrenheit is 212 degree Fahrenheit. The intermediate temperature will be the temperature in between the steam and the ice point, and the general symbol for that is Tx, while the intermediate under centigrade will be represented by Tc. C here represents Celsius or centigrade, while the intermediate of temperature in Kelvin will be represented by Tk, and that of Fahrenheit will be represented by Tf. Lastly, the ice point, which is the temperature of melting ice, under the general symbol will be represented as S0. Under temperature in Celsius will be represented as 0 degrees Celsius, while the ice point of temperature in absolute Kelvin, absolute temperature or temperature in Kelvin will be 273 Kelvin, while the ice point of Fahrenheit is 32 degree Fahrenheit. Now, having understood the various steam point and ice point of the different temperature scale we have, we also need to consider the temperature interconversion. And the first one we shall be considering will be between Kelvin, temperature in Kelvin and degrees Celsius. For example, we have the general formula for conversion. The temperature in Kelvin will be temperature in degrees Celsius plus 273 Kelvin. I repeat, temperature in Kelvin will be equal to temperature in degrees Celsius plus 273 Kelvin. That is how to convert temperature in degrees Celsius to Kelvin. That means you can convert temperature in Celsius to Kelvin by adding 273 Kelvin. For example, considering 20 degrees Celsius in Kelvin will be 20 plus 273 Kelvin, and that will give us 293 Kelvin. Now, having understood the interconversion of Kelvin and Celsius, the next one we shall be considering is Celsius and Fahrenheit. Now, for interconversion between temperature in Celsius and Fahrenheit, we use Tc, that is temperature in Kelvin over 100, equals Tf minus 32 over 180. I repeat, the interconversion of Celsius and Fahrenheit can be done using the equation Tc over 100 equals Tf minus 32 divided by 100. That is got from the intermediate point minus ice point over steam point minus ice point of both temperature. Now, for conversion between X, temperature in X and degree Celsius, that represents the general symbol. Then we use Tc, that is temperature in Celsius over 100 equals Ts minus X0, that is intermediate temperature minus ice point over steam temperature minus ice point of that temperature in X. And lastly, between S and the temperature in Fahrenheit, we use S minus Ts minus S naught over x100 minus x naught. That is intermediate temperature minus ice point over steam point minus ice point will be equal to the intermediate temperature in Fahrenheit minus ice point of Fahrenheit over steam point of Fahrenheit minus ice point of Fahrenheit. So generally for any temperature, we find the intermediate minus ice point of that temperature over steam point of the temperature minus ice point will be equal to that of the other temperature. Now, having understood the various ways of interconversion of the temperature scale, the next we shall be considering now is the UTM sample questions. And the first question we shall be considering comes from 1978, number 17. And the question goes thus: a temperature of 20 degrees Celsius is same as dash. So you have option A to be 36 degrees Fahrenheit, option B to be 68 degrees Fahrenheit, option C to be 11.1 degrees Fahrenheit, option D to be 43.1 degrees Fahrenheit, option E is 25 degrees Fahrenheit. Now, in solving this, we'll introduce a method of sketch in which the upper part, the sketch of E shape, the upper part will be steam, the middle will be intermediate temperature, while the lower part will represent the ice point. So for temperature in Fahrenheit, the steam point is 212 degrees Fahrenheit. The intermediate point will be represented by theta degree Fahrenheit, since we don't know the value, while the ice point is 32 degrees Fahrenheit. That is constant. Then in comparison with degree Celsius, the ice point of degree Celsius, temperature in degree Celsius is 100 degrees Celsius. The intermediate is given to be 20 degrees Celsius, while this ice point is 0 degrees Celsius. I repeat, the steam point of temperature in Celsius is 100 degrees Celsius. The intermediate is given from the question as 20, while the ice point is 0 degrees Celsius. Now, as usual, in converting this, we'll pick the intermediate of temperature in Fahrenheit minus ice point of Fahrenheit over the steam point of Fahrenheit minus ice point of Fahrenheit will be equal to the intermediate temperature in Celsius minus ice point over the steam point in Celsius minus ice point. And if we substitute for that, it will give us the intermediate value under Fahrenheit is unknown, so it's represented as theta minus the ice point, which is 32, over the steam point, which is 212, minus the ice point, which is still 32, will be equal to the intermediate in Celsius, which is 20, minus the ice point, which is 0, over the steam point, which is 100, minus the ice point, which is 0. So if we can solve this further to get theta minus 32 over 212 minus 32 will give us 180, which will now be equal to 20 minus 0 is the same thing as 20, then over 100 minus 0, which is 100. Then we can cross multiply. If we cross multiply, we'll get 100 into theta minus 32 will be equal to 20 times 180. So then we can open the brackets to get 100 times theta will give us 100 theta, minus 100 times 32 will give us 3200, will be equal to 20 times 180, which is 3600. Then we can collect the like times. When we collect the like times, that will give us 100 theta will be equal to 3600 plus 3200. So 100 theta will be equal to 6800. Then we can make theta the subject by dividing both sides by 100 to get theta equals 6800 divided by 100. And that will give us theta equals 68 degree Fahrenheit, making option B the correct answer for this particular question. The next question we shall be considering comes from 1979, number 14, and the question goes thus: the height of a mercury thread in a mercury in glass thermometer when in melting ice and then in steam are 3 cm and 18 cm respectively. At a temperature of 60 degrees Celsius, the height will be dash. So we have option A to be 7.5 cm, option B to be 9 cm, option C to be 10.8 cm, option D to be 12 cm, option E to be 12.6 cm. In solving this also, we'll write out the ice, the steam point, and the intermediate point. So for the mercury in glass thermometer, we are given the steam point to be 18 cm, which represents the upper part of the E shape. Then the middle point, which is the intermediate point, is unknown, which can be represented by X, while the ice point is given to be 3 cm. In comparison with the temperature in Celsius, as usual, we know the steam point of Celsius is 100 degrees Celsius. Then the middle point, which is the intermediate point, is given as 60 degrees Celsius, and the ice point is 0 degrees Celsius as discussed earlier. Then in solving also, we compare the temperature by using the formula the intermediate temperature minus ice point over the steam point minus ice point of the mercury in glass thermometer will be equal to that of the temperature in Celsius. So in substituting for that, our intermediate temperature, which is X, unknown under mercury in glass thermometer, minus the ice point, which is 3, over the steam point, which is 18, minus ice point, which is 3, will be equal to the intermediate temperature in Celsius, which is 60, minus 0, which is the ice point, over the steam point, which is 100, minus the ice point, which is 0. So we can solve this further to get X minus 3 over 18 minus 3 will give us 15, which is now equal to 60 minus 0, which will be 60, over 100 minus 0, which is 100. Then we can cross multiply. When we cross multiply, you get 100 into X minus 3 will be equal to 60 into 15. Then we open the bracket to get 100x minus 100 times 3 will give us 300 equals 60 times 15, which is 900. Then we collect the like times by transferring minus 300 to the other side, and that will give us 100x equals 900 plus 300. So 100x is equal to 1200. We can make x the subject by dividing both sides by 100 to get x equals 1200 divided by 100, and that will give us 12 centimeter, making option D the correct answer for this question. Now the next question we shall be considering comes from 1995, number 26, and the question goes thus: a well-lagged bar of length 100 cm has its ends maintained at 100 degrees Celsius and 40 degrees Celsius respectively. What is the temperature at a point 60 cm from the outer end? So you have option A to be 58 degrees Celsius, option B to be 62 degrees Celsius, option C is 64 degrees Celsius, while option D is 76 degrees Celsius. Now in representing this, we also use the E shape. We are given 40 degrees Celsius, 100 degrees Celsius and 40 degrees Celsius respectively for the Celsius scale. So, and they want us to find the temperature that will be at the middle of this. Then on the other scale, we are given the steam point, which is 100. Then we are given which is 100 apart, means between 0 and 100, meaning that the steam point will be 100 while the ice point will be 0, and we are asked to find the temperature at 60 centimeter point. So 60 centimeter will be between 100 and 60 if we want to will be between 0 and 100 if we want to locate it. So the 60 centimeter will be placed between 0 and 100. Now, while its counterpart on degree Celsius will be x. So in solving this, we get x minus 40 over the steam point, which is 100 minus 40 again, will be equal to the steam point on the other scale, which is the intermediate on the other scale, which is 60, minus the ice point, which is 0, over the steam point, which is 100, minus the ice point, which is 0. So if we solve for that, we have x minus 40 over 60 will be equal to 60 minus 0 will give us 60, 100 minus 0 will give us 100. Then we can cross multiply. If you cross multiply, you get 100 into x minus 40 will be equal to 60 times 60. Then we can open the bracket. If we open the bracket, we get 100 times x will give us 100x, minus 100 times 40 will be 4000, equals 60 times 60, which is 3600. So we can collect the like terms by transferring 4000 to the other side to get 100x equals 3600 plus 4000. That will give us 100x equals 7600. We can make x the subject by dividing both sides by 100, and that will give us x equals 77,600 divided by 100, making x to be equal to 76 degrees Celsius, making option D the correct answer for this question. Now on to your own practice question, and the first question we brought here for your practice comes from 2013 type D. That is question number 16, which goes thus: calculate the length which corresponds to a temperature of 20 degrees Celsius if the ice and steam point of an ungraduated thermometer are 400 mm apart. You have option A to be 20 mm, B is 30 mm, C is 60 mm, D is 80 mm. The expected answer here is 80 mm. That is option D. And the second question for your practice comes from 1998, number 17, which goes thus: a platinum resistance thermometer records 3.0 ohm at 0 degrees Celsius and 8.0 ohm at 100 degrees Celsius. If it records 6.0 ohm in certain environment, the temperature of the medium is dash. You have option A to be 80 degrees Celsius, B is 60 degrees Celsius, C is 50 degrees Celsius, D is 30 degrees Celsius. Expected answer here is 60 degrees Celsius. Our next video will be on linear expansivity with sample questions and solution from UTM. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you more interesting lecture on subjects related to UTM. Thank you.